Welcome to The Explainer. Today, we're going to follow data on this incredible journey it takes, starting as total, messy chaos and ending up as a powerful business insight. We're going to pull back the curtain on the unsung hero of the data world, the data warehouse.
So let's kick things off with a question that really gets to the heart of the problem. For a small shop, sure, a spreadsheet works just fine. But what happens when you're dealing with millions of transactions coming from dozens of different systems, all speaking totally different languages? Well, that is the exact problem data warehouses were built to solve.
So here's our game plan. First, we'll dig into the problem of data chaos. Then we'll follow the data as it travels through a process called ETL. After that, we'll peek inside the warehouse itself, see how it's all organized, then get to the big payoff, and finally, we'll see how it fits in with the whole data family.
All right, let's dive right into our first section, the problem of data chaos. To really get why a data warehouse is so important, you first have to understand the sheer scale of the mess it's designed to clean up. For any modern business, it's a total tidal wave of information.
Just think about it for a second. You've got your sales team using Salesforce, your marketing team is on HubSpot, customer support is using Zendesk, and finance has its own system. All this incredibly valuable data is stuck in its own little silo. And trying to get them all to talk to each other to get one clear picture of a customer? Yeah, good luck with that. It is pure digital chaos.
So, this is where the hero of our story steps in, the data warehouse. And let me be clear, this is not just another database. It's a highly specialized system. Think of it like a central library for the entire company. Its one and only job is to pull in data from all those different sources, clean it up, and create a single, trustworthy source of truth for everybody.
Okay, this brings us to a really crucial distinction. The databases that run your everyday business, the ones that process sales at the cash register, are called OLTP systems. They're built for one thing, speed. But a data warehouse is an OLAP system. It's built for something completely different, answering big, complex questions by looking at huge amounts of historical data. They're fundamentally different beasts, built for completely different jobs.
Okay, so that brings us to our next big question. We know we need to get data from all those scattered places into our central warehouse. But how does that actually happen? Well, there's a famous three-letter acronym for this process, ETL. It stands for Extract, Transform, and Load.
It's a three-step journey. First up, you extract the data. You're basically just copying it from all those different source systems. Then comes the most important part, the transform step. This is like a data car wash. It happens in this temporary staging area where you clean up all the messy stuff, standardized formats, like making sure USA and United States both mean the same thing, and get it all consistent. And finally, once it's sparkling clean and ready to go, you load it into the warehouse.
And this visual right here, it perfectly captures that idea. You can think of the ETL process as being like a super meticulous librarian. This librarian goes out to all the different departments, gathers up their messy, disorganized books, that's the raw data, and brings them to a back room. There, they fix the torn pages, standardize all the covers, and give every book a consistent catalog number before and only before putting it on the shelves of the main library, our data warehouse.
So, the data is in. It's clean, but how is it all organized? Because it's not just dumped into a giant folder. The way it's structured on the inside is the secret to its incredible speed and power. And honestly, this is where the real magic happens.
Okay, so here's the first secret weapon. Most data warehouses are what you call a columnar database. Now, your typical day-to-day database stores data in rows, like a spreadsheet. But a columnar database stores it in columns. Why does that matter? Well, if you want to know the total sales for the last year, the database only has to read that one sales column. It can completely ignore all the other columns, which makes your query blazing fast, even if you have billions of rows.
And the second piece of the puzzle is how it's all structured, which is usually something called a star schema. And don't let the name scare you, it's actually beautiful in its simplicity. Right in the middle, you have your fact table. This is where you store the numbers, the actual events, like a sale amount, or in this example, a book loan. Then, all around it, you have these dimension tables that give you the context, the who, what, where, and when. Who was the customer? What was the book? When did they check it out? It makes finding what you need super intuitive and, again, really fast.
So this structure, this web of facts and dimensions, people often call it a data cube. And it's this cube that lets us do some really cool things with the data, to slice and dice it in different ways.
These are called OLAP operations, and let's quickly walk through the 4 big ones.
First up, you can roll up. Think of it like zooming out on a map. You're taking detailed data, like sales from every single city, and you're aggregating it or rolling it up to get a bigger picture, like the total sales for the entire country.
And of course, if you can zoom out, you can also zoom in. That's called drilling down. It's the exact opposite. So you might start with the total sales number for the year, and then drill down to see how it breaks out by quarter, and then drill down again to see it month by month. You get more and more granular.
Next, you can slice the data. Imagine that data cube we talked about. A slice is literally like taking a knife and cutting off one single slab to look at. So we could slice by the time dimension and say, show me all sales for all products in all locations, but only from the first quarter.
And last but not least, you can dice it. Now, if a slice is a whole slab, dicing is like cutting out a tiny little cube from the center using multiple criteria. You're zeroing in. For example, show me the sales of just modems, just in the city of Toronto, and just during Q1. That's dicing.
All right, we've extracted the data, we've transformed it, we've loaded it, and we have it perfectly organized in this beautiful star schema. That was a lot of work. So, why? What is the big payoff for doing all of this? Well, it all comes down to answering these 4 critical business questions, and sort of moving up the ladder of insight. It lets a business go from just describing what happened to diagnosing why did it happen, and from there to predicting what will happen next, and finally to the holy grail, prescriptive analytics, which tells you what should we do about it. This is how you go from being reactive to being truly strategic.
And this is where the rubber meets the road. All that clean, organized, trustworthy data becomes the fuel for everything. It powers the live dashboards that executives look at every single morning. It feeds the complex models that forecast revenue. It enables the deep dives into customer behavior that shape entire marketing campaigns. It's the engine behind truly smart, data-driven decisions. All right, to finish things off, let's zoom out a little and see where the data warehouse fits in the bigger picture, because it's not the only player on the field. It has some really important relatives, like data marts and, especially, data lakes. Probably the most important comparison to understand today is the data warehouse versus the data lake. If the warehouse is that pristine, curated library with neatly cataloged books, a data lake is more like a massive natural reservoir. It can hold a staggering amount of raw, unfiltered data in its native format, structured, unstructured, video, audio, you name it. The structure is applied when you read the data, not before. This makes it incredibly flexible and an absolute powerhouse for things like machine learning and AI.
And you know, this isn't just theory. You've probably heard of some of these names. They're the real-world tools that make all this happen. You've got Snowflake, which is famous for brilliantly separating its storage from its computing power. Amazon's Redshift is a classic columnar powerhouse. Google's BigQuery is serverless, which makes it amazingly easy to use and scale. And of course, Azure Synapse ties in perfectly with all of Microsoft's other tools. They all bring these concepts to life.
So, there you have it. The data warehouse was this brilliant answer to the chaos of business data. It turned scattered files into strategic wisdom. But now, as we're plunging headfirst into an age of AI, where data is growing exponentially and taking on all these new forms, it really leaves us with one final big question to think about. What's the next kind of library we're going to need to invent to make sense of it all? Thanks for joining us on The Explainer.